The effective stress principle. Soil mass is a three-phase system consisting of a skeleton of solid particles parked with interstitial spaces called pores. An element of soil at depth h in the soil experiences stress due to the weight of overlying soil, referred to as geostatic stress, and additional loads coming from structures on the ground surface, such as buildings. For this discussion, let us consider just the geostatic stress at a point within a saturated soil mass. The soil is completely dry if the pores are filled with only air, partially saturated if the pores are filled partly with air and partly with water, and fully saturated when the pores are only filled with water. Because the soil solids and water have mass, they exert weight force on underlying particles. Because the pore spaces within soils are considered continuous and the surface of the water in the system is open to the atmosphere, there will be water pressure at this point due to the water column above the point. Let's take an arbitrary horizontal plane through the soil. Know that since this plane is only allowed to pass through the inner particle contact points at depth h without cutting through the individual solid particles, this plane appears wavy in a closer look. However, when considered on a mass scale for practical applications, this plane will appear perfect. Hence, it is okay to conveniently consider the plane a perfect horizontal plane. The inner particle contact forces, which is random in magnitude and direction, can be resolved to obtain their upward vertical components normal to the plane. Let the area of the plane be equal to A. The inner particle contact area is AS, and pore pressure is lowercase u, acting over an area AW. Then you have total area as AW plus AS. Since the soil is in equilibrium, the sum of all vertical forces along the plane, which is equal to the total weight of the soil, the resultant vertical inner particle reaction forces, and pore pressure force equal to uppercase U, should balance out according to Newton's third law. Thus, you have W is equal to Fs plus U. Dividing through this expression by the total area, A, gives this expression. The total weight over area gives us total stress in a soil element, denoted by sigma. The actual contact area of solids generally range between 1 to 3%. Hence, it is convenient to assume AW is approximately equal to A. Thus, you have this expression, and hence, sigma is equal to Fs over A plus lowercase u. The quantity Fs over A is what engineers refer to as effective stress, sigma prime, and lowercase u as the pore pressure in soils. Hence, you have sigma is equal to sigma prime plus lowercase u. By this assumption, engineers are being conservative by overestimating pore water pressure and underestimating the effective stress value. It should be emphasized that although the effective stress was derived from the normal inner particle forces, the quantity does not represent the inner particle stresses. This is because a closer look at the typical soil structure shows that AS is significantly less than A, making the sigma prime far less than what the actual inner particle contact stress should be, Fs over As, and therefore represents the average stress that would be felt if the normal inner particle contact forces were acting over the entire plane through the soil. This is the effective stress principle, and it is regarded as the most important principle in soil mechanics.